Hello, welcome back to Sushi LiveNoding. In this episode, we're gonna really have a look at animation nodes, procedural animation capability, and it's gonna be pretty basics. Basically, we're gonna transfer one animation from another objects into another objects, and we're gonna offset the animations, and we're gonna do it procedurally. And so, yeah, let's just get started. First of all, we have a cube right here, and I guess we can animate this cube ups and down. That's the easiest we can do. Let's quickly keyframe in the z-axis, and then I'll go to another frame, and then quickly keyframe it again. And it's gonna move up like that, and gonna keyframe it again at frame 0, insert single keyframe, and we have these animations, just the cube going up and going down. Okay, so nothing special with that. I'm gonna save this real quick. AN animation transfer offset. And let's say we want to transfer the animations into the monkey head. Now, instead of just copying the object transform from this guy to another guy into the monkey head, we're gonna actually observe the F-curve. So we're gonna switch to animation first. I'm gonna select this box object, and then currently we have these animations, and we can actually easily just cycle the animations just for simplicity. So I'm gonna use this modifier, and I'm gonna turn on the cycles. This animation is gonna do the cycling. And so yeah, we're gonna transfer these animations ups and down into the monkey head, and we can do it in many different ways. And we can basically, just like driver, we can pass in the ups and down animations into the monkey head, whether it's controlling the one of these attributes like X, Y, Z, or rotations or scaling. We can actually control anything using that single F-curve. So switch to animation nodes, new, and let's grab this guy. Just get an F-curve. So let's find the nodes we need first of all. F-curves from objects, that's what we need. Gonna get a cube, and this cube, you can see the F-curves is actually like kind of a half opacity. That means this is kind of like a list of attributes, because this cube object might have multiple animations, let's say the scaling or the locations. So each attribute will have a single F-curve correspond to the objects. And so that's why we have this list of F-curves instead of a single F-curves. So that's important. Let's say we have like a multiple monkey head, and we're gonna group this guy, Control G, and we're gonna get the objects, and we want to animate this head to follow this motion. The way to do it is that here we're gonna use loop. I'm gonna tap W, loop through every single objects, and we're gonna pipe in this F-curve. Now the way we put the F-curves is not into this new iterator. We're gonna pipe it in through the new parameter. So it's gonna be F-curve list, and actually this can be F-curve list, or actually it doesn't matter for now. Just F-curve list, and we can observe it inside the loop. So for each object, we can control the object transform. For example, for these animations, we can transfer it into the scale of the objects, for example. So instead of moving the objects up and down, we're gonna just scale the objects based on this F-curve. So we can't just pipe this into that, guys. It won't understand it because we need to convert the F-curve data into just numbers. So we need to perhaps evaluate it. But it's a good idea to look at the F-curve info first of all. So this guy not gonna work because why? Because this is like a list. We need to pipe in the proper value. So I think get list element, that's what we need. Probably it's a good idea here to just get the F-curves that we need. I just realized this. So like I said, we have like multiple F-curves coming in, and this data can be any F-curve from any of these attributes from the cube objects. We can observe it real quick like this. So current data path is apparently locations. Array index is index number 2, which is the Z. So that's the curve we have. We don't have any other data. So we can pipe this into this F-curve. So now this thing is inside, and we can evaluate it, and we can pipe this value into the scale. And now we can see our monkey head is scaling ups and down based on this number right here. We can also observe the number inside the loop here. If we want to properly like observe value inside the loop, we need to use loop viewer, pipe in the data there, and let's look at it inside text objects. There should be 4 numbers, you see? Okay, so I think this frame number is the offset. If we pipe in the index into that guy, now the object is kind of slightly offset by the frame. Hopefully that's kind of clear enough. It's probably, instead of scaling, I just gonna switch to the z-axis, okay? So I'm gonna pipe in the value from this cube object into the monkey head as just the z-axis. So combine, we need to have this combine vector, and because we're gonna create this vector value, but we're just gonna pipe in the z. Okay, now you see the monkey head is slightly offset because of this index. The index is actually like a 0, 1, 2, 3 based on the number of the objects. We can have a look here if we pipe in the index into the loop viewer. So in order to offset this a little bit more, we can use math and kind of multiply the index by a value. So now they're kind of looping, and then we have like a larger offset for each object in terms of frame. Now this is actually very, very cool. What's happening here, animation nodes kind of like generating multiple timeline, even though it's not so visible. But this guy right here, with evaluate F-curve, we can specify an offset of a frame, or we can specify also the absolute frame number. So with absolute, we really have control over the frame, and we can pipe in like a multiple frame. So we can basically generate our own timeline, multiple timeline, and then type it in here with this absolute, and then we can kind of offset the time and offset the time using index, and then kind of multiply it as well. So this is actually really, really powerful. Now we can kind of slow down the time and things like that. We can, by slowing down the time, the animation also is going to be a little bit slower. So let's try doing that. Half the frame animations, it's going to be half slower, or even like slower, or even faster. This animation of the box doesn't change, but you see the monkey head is like 3 times faster. So I think that's really, really cool, and we can have like a more monkey head. We can actually use like object instancer to do it. Just gonna duplicate it manually. So now we have all this bunch of monkeys animating in the z-axis in random, kind of slightly offset. Okay, so yeah, and it's all actually still dependent on this cube. So if we have these monkeys keep moving, and we're gonna switch to the animation graph editor. Now simply look at this cube and look at this graph of the animation of the Z location. If we actually add like a noise, you can see that the monkey also get affected, because this modifier for the animations, the noise, is affecting this the cube, of course, and also affecting the monkey. And we can, of course, because this is like a modifier, animation modifier in Blender, we can change the properties, and we can get different kind of effects on the monkey. So in terms of how animation nodes can be really powerful, is that with the FCurve, we don't just like pass in the animation from this guy to this guy. We can offset them, we can change the value, we can also kind of add all kind of noise, wiggle value, multiply, blend the animations, things like that. And we can, of course, like I showed you before, we can pipe in the scale, for example, the scale, pipe in the value from this guy into the scale, and like that. Okay, I just fix it. And the cool thing about this is that we can also use vector math and kind of adjust the value here. We can even like offset it if you like. Just add the value into this guy so it doesn't go to 0. Again, just slow it down. So these animations is still controlling all the monkey head, but controlling it, kind of driving it in different ways. Now if we go back to the animation graph, we can actually just use add and then play around with the noise, get different animation. So a single animation curve can be offsetted into this monkey head. And yeah, you can have a lot of monkey heads, for example. But of course, animation nodes is actually very, very powerful in a way that you're not dependent on just a single monkey head. You can use object instancer. So if we, for example, if we use like a object instancer, and we get the monkey head, right here and make like 10 of them. And we pipe in into this guy. We should have like a 10 monkey head here. And we can also randomize the location. Generate random head with a count of the number of the objects. It should be this one. Type it into that guy. Oh, actually this should be, okay, this should be the index vector. So now we have 10 monkey head, each one of them with a slight offset of the scale. So this is the master, Suzanne. This is the master head for the object instancer, and this is the animations that we generate using the cube. And we can have like more monkey head. And yeah, so we end up with this kind of animations. It's all still being controlled by the animations in the graphs, like this cube right here, which we cannot see right now. So this cube, I'm just gonna move it to the left. So the cube is controlling the instance of this monkey head. So I think it's really, really powerful. You can always go back to this animation and just adjust this as you like. Let's have a look. Okay, we have just a tree animation right there. I can make the animation like that, for example. Not sure it's gonna loop properly, maybe not, but you can see that it's affecting all the monkey head as well. So yeah, a single F-curve can be very powerful once you kind of copy and offset it into all multiple head like this. Yeah, so that's a quick look at animation nodes and procedural animations, how you can easily copy a single F-curve into all these instance objects. Yeah, hopefully this is useful. Thanks again for tuning in, and I'll see you in the next video. Thank you. Bye.